Hello and welcome to Additive Insight, the original additive manufacturing podcast and your source for news, interviews and comment on the latest 3D printing and AM intelligence, brought to you by TCT Magazine. I'm your host Sam Davis and today I'm joined by Firestorm Labs CTO Ian Muceus. Firestorm Labs is a manufacturer of mission-adaptable unmanned aerial systems and is a big proponent of additive manufacturing technology. The company has a portfolio of additive-enabled drone products, including its flagship Tempest UAS, and has also developed the semi-automated xCell manufacturing platform, which utilises multi-jet fusion technology within 20-foot containers. As he joins the Additive Insight podcast, Muceus provides detail on the capabilities of both Firestorm's drones and the xCell platform, while sharing his perspective on the impact AM is having within the drone space. Muceus also explains how the company will utilise the funds raised in its recent Series A round, and tells us how Firestorm's application of AM may evolve moving forward. If you like what you hear, don't forget to subscribe wherever you get your podcasts. You can also head over to tctmagazine.com to subscribe to the TCT membership platform and receive more Additive Insight via our print and digital offerings. Ian, welcome to the Additive Insight podcast. We'll talk today about how Firestorm is leveraging additive manufacturing in the development and manufacture of drones and unmanned aircraft systems. But first, can you tell us about your background and how you came to co-found Firestorm?
Yeah, so my background is additive manufacturing for the past about decade. Before that, a bunch of software startups. And prior to that, I was an aerospace engineer out of Cal Poly SLO. And so, a good university steeped in a lot of, aerospace prowess and folks like Burt Rutan, matriculated there. And that's actually sort of where my additive journey started. I won a design competition through a 3D printing company at that time, SLA, and they printed basically one of the first aircraft that I designed for my senior design course. And from there on, it was like embedded in me that it would be interesting throughout my career, and it just was kind of like, when was I going to re-engage with it? In software, I kind of learned I like software a lot, but doing kind of the same thing over and over again and running the same kind of playbook in software got old for me. So I had the opportunity to move to Origin Laboratories, which was a startup in the DLP space in San Francisco. And the reason that I went there was because they were going after this kind of open material network. I was the first kind of hire on the business side, basically, to take over all of aerospace and defense, the business aspects of the company. And I love that they were doing the open material network because I'm a big fan of those ecosystem plays and networks where really you can get other people to build stuff for you. That's kind of what it's all about. And I'd just done that at Segment, which is a software startup, and that kind of just kicked the tires for me and wanting to continue that throughout my career. Love the DLP space. So many good things about that process. So many good things about the material sets. And then Stratasys acquired us. I worked there and leading aerospace and defense for a bit. And then really decided that, the larger kind of companies weren't necessarily for me, and I really wanted to be in the startup space. I met my co-founder, Dan, through a Navy SEAL friend of ours, and he had worked at the NSW kind of innovation center. And so I'd done 3D printing stuff for the SEALs. Dan had done counter UAS stuff for the SEALs. And so we sort of combined that knowledge and then picked up Chad, our third co-founder, a few months later, and, formed the dream team, as it were.
Okay, so you, Dan and Chad, as you started Firestorm, looked at the kind of existing state of unmanned aircraft systems back then, a few years ago. What did you see when it came to the kind of opportunities for innovation?
Yeah, it's an interesting question because right when we started the company, what was also happening was the war in Ukraine was kicking off. And so Dan had the insight from his work in counter UAS that these new kind of small FPV style drones were going to play a critical role. What he saw with his previous company, Citadel, in northern Iraq and Syria, was that folks were taking DJI drones and they were dropping things like mortars and IEDs on our troops and coalition troops, and so it was a really negative thing. And so as those things started to pick up in the war in Ukraine, And as we, obviously had Chad, he's a 23-year tier one special operator. We had these insights around the fact that legacy systems that cannot adapt fast enough, so really systems that have pretty locked designs or have really optimized around a singular or particular mission set, are really going to be left in hangars and left almost for ruin. What we were seeing in Ukraine is that you really needed to adapt at the speed of the battlefield. And so folks who weren't doing that, and folks whose systems were too expensive, and I don't say this like figuratively, they are literally sitting in hangars because they will not be used because they can't keep up with the sort of cat and mouse game of offensive and defensive kind of asymmetry. And so we wanted to create a vehicle that could adapt to all that and adapt quickly enough. And that's sort of where additive really came in, is like what allows you to adapt really quickly. Well, if your parts are additively manufactured, you can change those for low labor and low turnaround times and low cost generally. And so that's where additive really came into the picture there. And subsequently, right, it's been a huge part of everything that we've done. But yeah, that insight effectively of you're going to have to change and modify your vehicle, and any one fixed design will not win the fight.
Yeah. The first product I think that you guys kind of developed and put out there was the Tempest. Is that right?
That's right.
So can you tell me about the capabilities of that product? What can that UAS system do?
Yeah, so Tempest at its core, it's a Group 2, Group 3 aircraft. So what that means, Group 2 caps the maximum takeoff weight, or MTOW, at 55 pounds. Sort of arbitrary. It actually kind of pisses me off because it limits, who can use your aircraft. Some people use Group 2s, some people have, are trained on Group 3s and above. There's all these training requirements. So it's kind of an annoying arbitrary limit, if I'm honest, because our aircraft ends up weighing between like 55 and say like 75, 85 pounds. And so anyway, that's sort of annoying to me. But why it ended up kind of that large is we really looked at what's the payload capacity that we wanted to carry to be really utilitarian for our allies and the US. We looked at what are the ranges and capabilities that we need, and we developed a vehicle also around the limitations of the print process. So basically it's not, but let's call it 15 inches on end is kind of the largest part we can build. So that was really a limitation on segments of the aircraft, as you kind of have this Lego looking aircraft put together by these sections. And so Tempest has multimodal propulsion. So its core propulsion in the early days was a turbojet. We were really looking at this being a one-way attack kind of vehicle. So turbojet powered, limited range, because turbojets have really terrible thrust-specific fuel consumption. That's why no aircraft today, they all have these massive ultra-high bypass ratio turbofans and all of this. But it was a good start because in the RC world, there are kind of RC hobbyist grade, prosumer grade, whatever you want to call them, turbines, and they're actually very low cost. When you look at the entire powertrain's cost, I can go get a turbine that costs like $2,500. If I go look at getting an internal combustion engine, even an RC grade one, you're maybe in for $1,000, but you fly longer, so then you need a generator. That generator kicks up the cost to more like $10,000 for that engine. And then you look at, the batteries that you need, et cetera, and your powertrain, you see how it gets more expensive. So for us, the turbojet powered Tempest is a one-way attack, lower cost variant. And then basically the aircraft being super modular, we've created this foundational architecture that's kind of all of your avionics, your core, center wing section, et cetera. And then we can literally remove the entire empennage or tail section of the aircraft and replace that turbojet section with a diesel fuel cell into a pusher prop version of the aircraft with an internal combustion engine, electronically fuel injection setup with a generator, and drastically changed the vehicle. So we also changed the wing, we changed modify some other things between the two different varieties of the vehicle, and you get wildly different performance specs. So really what we went for is how can we create this super utilitarian vehicle that can change basically everything about it and do so very easily through our kind of fully vertically integrated software and hardware stack.
Okay. On that product, to what extent was 3D printing used in the development and the production?
Extensively. So throughout its entire, like at one point, literally, this is kind of crazy. The first time that we ever flew it, it flew on the first flight, by the way. It crashed subsequently, but it flew. Um, it was entirely 3D printed. I'm talking, there was no spars, no carbon fiber, stiffening members. It was an entirely PA-12 multi-jet fusion printed aircraft structurally, and it flew. And yeah, we had, our wings were doing, we're flexing like crazy. Wingtip deflection was insane, and that's what ended up crashing. It is wingtip deflection actually squeezed the ailerons, and then we couldn't maneuver anymore. But it really showed this aircraft that's has 50 plus 3D printed parts, was super viable, and we could do it with a process where we could again basically digitally modify parts super simply and have an entirely different aircraft like the next day. And so today we're moving towards a little bit different construction. We work kind of monolithic segments, if you can imagine, kind of one wing section printed kind of as a monolithic structure. Same with fuselage sections. Now we're moving towards a construction that allows us to kind of part those out and then assemble them in a little bit of a different way. Makes us stronger, lighter, etc., and allows us to actually have way more throughput through the 5600 series MJF system from HP.
Okay. A couple of other products that are listed on the Firestorm website, the Hurricane and the El Nino, are both in advanced development. So as the capabilities and requirements have increased of those products, how has the application of AM evolved, if at all?
Yeah, so we're still very much on the AM train. I don't think we'll ever get away from that. I'm a big advocate. Obviously, it's been all my life. And there are parts where I think we will be able to move into other technologies, injection molding and such. But yeah, both of those vehicles are still almost entirely structurally, aerostructurally PA-12. And the thesis behind that again is, if you're going to go out and design aircraft that need to be super, strong, stiff, lightweight, do you go with PA-12? Like, no, you don't. That's crazy. If you are using that as your or as your main design points, and what I used as my main design points in the early days is really cost. What's the most ubiquitous powder out there? Well, it's PA-12 in the MJF space. All of these service bureaus and contract manufacturers use it. So why not design around cost and design around availability of materials, both in the United States and globally, as a key constraint in that trade space? And that's really what we did. And so, it was something maybe that other folks wouldn't really focus on. And being an aerospace engineer myself, I want everything sexy, carbon fiber this, carbon fiber that. But then your machine is expensive. Your process of building it is laborious and in many cases not able to be automated. And you constrain your upper volume as well, potential of your process. So it's a weird circuitous way to get to PA-12 and MJF, but here we are.
Yeah, on MJF, something else that you've been working on, and I think it goes back to kind of the original motivation of the company is the xCell system. In 2025, you announced an extension of your partnership with HP to utilize MJF within the xCell. So tell us about what the xCell system is first, and I guess what the thinking behind that system is.
Yeah, so trying to think of the exact year. It might have been 2019, 2020. I was working a lot with X1 on some metal binder jetting projects, and they had put in a SIBR for so Small Business Innovation Research Program grant, basically for metal additive at the edge in a 40-foot container. And so I was working with them a little bit, kind of consulting on that. At Origin, we had also put DLP 3D printing into hard cases and shipped that to the edge, basically made like a mobile lab, if you will. And the reason in both cases for doing so was that, again, I say utilitarian a lot, but like whenever you land in a differentiated place at the edge, at forward operating bases, whatever it may be, you sort of have what you have. And if you don't have the means to produce something or to repair something, you are literally waiting for resupply, or you could, in some cases, be dead. Like it could be the end. And so thinking about offering up differentiated and asymmetric capabilities to our warfighter was really what all of that was about. How do we push means of production closer to the fight? And not saying that that's the only thing. I think when some people see xCell, they get caught up in like, oh, that's the only way that you're going to manufacture. Absolutely not. It's imagine an xCell at every NATO base around the world, at every US base around the world, every ally base. xCell is there to be a utilitarian, means of production to basically produce, say our assets, great. But remember, it's an additive manufacturing machine. So it's a 5600 in a really nice, self-contained environment that can be pushed, really anywhere. If you can set up a generator and have some diesel, you can be printing in a couple of hours. And so it's about producing our vehicles and creating this network globally that can then also produce other people's vehicles, produce spare parts, produce things that break, and create, almost like the fourth network for us. So our first network, I would say, for production is kind of like our fixed lines in our facilities. Then we have our US-based contract manufacturers, service bureaus that all run the same printers. Then we have our OCONUS or outside of the US facilities that do the same. And then we have our xCell network. And so we're truly building this distributed production network, which is really what additive has always, like that's always been the kind of promised land, right? Is I can produce near where it's needed. This is happening in dental all the time, right? Chair side dental is a big thing. So we're really just taking kind of a chapter out of that book, if you will, and trying to hyper enable our warfighters, which, by the way, like have used additive for a long time at the edge. There's been labs and different things that have really helped them in a lot of cases. Where I think we differentiate is how do we create high volume manufacturing at the edge with our xCell system, and how do we build these kind of catalogs of parts, vehicles, entire systems that can be produced out of said xCell, and really provide a differentiated capability where it's not hey, 19-year-old kid, do you know CAD? Can you lay out a build? Can you just do support generation, etc. Not everyone can do that. We can kind of set them up with everything they need to do that in a really automated fashion.
Obviously, you mentioned before, as you're kind of developing the drone product, the technology that's out there, the materials that are out there, and that service providers know and use was part of your thinking. So as you built the xCell system, was it ever going to be any other technology than multi-jet fusion, or were you always thinking it would be multi-jet fusion?
Yeah, the reason for multi-jet fusion, well, I'll give you like a little inside baseball that not a lot of people know, because it was kind of a side hustle business at the time. But during the pandemic, at Origin, we were working on swabs. There were a lot of companies working on nasopharyngeal swabs, right? I had a side hustle business also working on 3D printing those adjustable face shield frames out of PA12. It was an open design by the Avid folks. And I basically worked with Avid and was able to supply over 1 million, pushing almost 2 million face shields to the state of Nevada, which is my home state. And so did that on the side, saw how scalable it was with like no CapEx money. I could literally leverage these networks of printers and produce, really meaningful revenue. And that was kind of the my jump into, I guess, MJF. And I know I was working at a DLP company at the time, but where MJF really came into to focus for me is that it's mature. It has a really good ecosystem around it and has a lot of adoption. So, is it the best process for everything? No, but it's low cost when you use it the correct way. You have really good networks of printers and folks that know how to use them. And really, as a startup, you can leverage that as a way to kind of get up and running without having to buy a bunch of really expensive capital equipment right out of the gate. So that is really the reason for using it. And then our partnership now with HP. You have exclusivity over HP equipment, 3D printing equipment put into the expeditionary world. So, if we're moving it around, it's exclusive to us. And why I think that's special is now with that relationship, we can kind of, I don't want to say like turn the screws on them, but, we get to help kind of product develop with them, do some co-product development and really try to, improve the system and future systems for our use cases. That extends to things like material development, et cetera. So it's been a really fortunate relationship, and we'll use other processes, other capabilities, but for now and for what we're doing for the foreseeable future, it's the best process for us.
Okay, cool. In terms of using 3D printing or additive manufacturing in the sector that you're kind of deploying it, obviously they're very capable products, high requirements, and obviously the need is very important. How is the technology performing? What's working well, and what could be better?
Yeah, let's see. I would actually say so. From an additive sense, really additive has not been the limiting factor in any of our vehicles and not really
Mm.
been an issue. I'll say, of course, sometimes you want a stiffer material, et cetera, and that could help with performance and maybe help in the case of certain aerodynamic events, like, if you're experiencing flutter or if you're, in high G maneuvers, a stiffer material would be good. But really the limfac or things that we run into that are issues with the aircraft are going to be issues that are shared by the broader, aerospace and drone market, which is communications,
Mhm.
jamming EW, how survivable is your aircraft through these different EW events. And so, folks are going to be shooting high power millimeter wave at you, HPM. Folks are going to be shooting lasers at you. There's going to be kinetic effects coming after you, so counter UAS kinetic effects. So really, it's been about how do we harden the vehicle's electronics? How do we make it a survivable aircraft? And that comes down to all the stuff that is really not AM, not structural, but really, electronics, your GPS, your types of antennas that you're using, how you're processing signals. So really, the things that are limiting factors for us are shared across the space, which is actually kind of nice because then we are still able to leverage additive to be our true like asymmetric advantage over a lot of folks in the space. And then there are other folks doing additive, but a lot of folks are using FDM, and I not to like poo-poo FDM, but I've just been blessed by starting in all of these kind of sexier technologies like DLP and MJF and binder jetting, and I like FDM. There's places for it, but as we know, right, it doesn't scale unless you create print farms to scale it. So
Mhm.
so I would say like additive is still very unique for us and gives us an asymmetric advantage, and it's really all the other stuff. And honestly, that's where it's problematic around cost and things like that too. We can create a really low cost aerostructure and airframe, and then a customer can say, hey, I want that camera. And that camera costs $75,000, $100,000, and now your cost paradigm is kind of blown out the window. So
Yeah.
those are the problems that we face.
Yeah, I wanted to ask about the cost comparison versus a traditional way of doing it. So if you forget
Yeah.
the kind of add-ons of a camera that might cost $75,000, the kind of structural components, AM
Yeah.
versus a traditional method, how is AM performing on a cost basis?
Yeah, very well. So, an aerostructure, let's say for a typical Tempest, all our 3D printing parts are, let's call it between like $3,000 and $4,000 for a big Group 2, small Group 3 aircraft. It's a very small portion of our cost. So, in that case, I think it's actually really asymmetric as well because, we don't have molds, we don't have fixed tooling. The really unique thing that we've been able to do. So, if you looked at your cost across all of your assets, molds, et cetera. If you were to do it any traditional way with carbon fiber layups or say you were injection molding, and you looked at all the revisions to that over time because you need to do that adaptation that I've been talking about, your costs would be astronomical. Like if you truly accounted for everything. What's been really special for us is we've done 10 major revs of Tempest, like completely different revs of Tempest, and thousands of dot revs. It's actually kind of insane how many small things we've been able to tweak. I wouldn't even want to look at the cost differential. It'd be so terrible. And a little bit of that is we know we can do it. So obviously we can make the small modifications. But yeah, so when you look at the cost per aircraft, I would say we would come in quite a bit below our competition that's using different molds and layup processes and all the labor that goes into that. We're putting aircraft together in 2 to 3 hours full assembly. That just is not happening with anybody else.
Yeah.
And that's final assembly, of course. There's print times, but yeah, print time is like we're working with HP. We've gotten print times down to about 6.5 hours for our builds. So end-to-end times for us are very low. They're mostly automated, right? Because your whole print process is automated. Your layup process, if you're a small shop, you're not doing like automatic tape layering or any of that stuff. It's very manual. So really, I think it's still just such a key kind of process for us, and again, why I don't think we'll move away from it in the near term.
Okay, that's interesting. One thing I wanted to ask today was about the fairly recent Series A round that Firestorm completed, raising around $47 million with the likes of Lockheed Martin Ventures, New Enterprise Associates, and JP Morgan all providing their support. As you move forward as a company, how will the company kind of use those funds? What's the plan in terms of leveraging that additional capital?
Yeah, no, great question. We're really fortunate to have a great set of investors, ones that have believed in us when defense wasn't hot. In our early days, we really had to convince people if like a 3D printed airplane could even fly. And it was a little crazy for me because like we've been doing this in academia for a decade. But people kind of sometimes in the space have to see it to believe it, and I respect that. So yeah, really where we're using that funding is we've grown a ton. We're up to about 120 employees now. We've moved into our fourth facility if you count my garage, I guess fifth if you count my dining room table. My wife kicked me off of that very quickly. But so we're now in 65,000 square feet, and we've also gone kind of bi-coastal. We have another facility in Rome, New York that will be opening soon. And so, yeah, it's a little bit about growth, or a lot about growth. It's a lot about spending and continuing to invest in R&D. We're still investing a high percentage of our revenue and our VC investments in R&D. As you spoke, like we're investing in new products. So we have El Nino, we have Hurricane, we have some other variants of those coming out. So a ton in basically making sure that we can continue to innovate, and then pay for all of our lovely staff, of course, and then pay for new facilities and expansion growth in that CapEx as well. So yeah, I would say we're efficiently using cash. It is a hard space, right? Like even in creating additive manufacturing systems, before something goes wrong with those, they smoke a component or whatever, you can go replace the component. If something happens with their aircraft, it falls out of the sky. So some of that has been where you spend some cash is aircraft are going to have catastrophic events and you got to rebuild. And then I would say we're doing quite a lot, right? We have the aerospace side of the house. We have the additive manufacturing and xCell side of the house. We're doing a lot in software, all based really on open source development as kind of our foundation, and then building that verticalized stack of how do we make our systems the most simple to use in the space, and really allow someone to learn one kind of ground control system software, be able to operate all of our aircraft. So we're really investing a lot in that as well.
Finally, and thank you for your time today. You mentioned earlier that you don't see Firestorm moving away from AM. So when it comes to the product roadmap, the development of new drone systems, what capabilities do you see AM opening up for Firestorm moving forward?
Yeah, what I think most excited about, obviously, if HP could make us a printer with like a 5 times larger build volume, we'd love it. No, but it comes back to materials all the time, right? I'm really excited about some of the new material development that we're going to be doing with HP, and they're doing with their partners as well, right? It takes kind of a village to really push the material development forward across the entire world, right? And some of those materials that I'm seeing in the early days will push things like strength and toughness up by like 50% or so. And what that allows us to do to things like wall thickness, which is in our parts, we carry most of the weight of the system in the skin thickness of our aircraft. And so where we can limit that, we're just going to see huge gains in, our aircraft's performance, range, endurance, these sorts of things. So that's really exciting. I'm excited to, we will leverage other technologies. So I'm excited to really look at, are we using binder jetting sand and casting motor cores for, internal combustion engines. Like, what are all the things that we can do as we start to kind of broaden out, our I guess our interest in other parts of the aircraft. Right now, we use a lot of consumer off-the-shelf components. And I think what you'll see, particularly because we're trying to move as many parts into, made in the US, or at least assembled in the US with all NDA components, is, what are all those other things that are interesting to go try to win, where we think additive can basically help us either change the cost paradigm, or, again, offer some asymmetry in performance. So we'll continue to kind of look into all of those things across all the fronts, and then, invest our time and money where it makes sense and gives us the best, advantage over the enemy.